All right, so I don't know quite what happened with problem number 45 and why the video uploaded but not the audio. So what I'm going to try to do right now is just watch the video that I already recorded and just kind of talk over it. So hopefully this is actually working. So exam 3 problem number 45, as we're setting it up right here, is a tricky little problem. It's not really like any other problem that we've ever done. So they tell you here that y equals mx plus b with a b value greater than or equal to 2 is tangent to a graph of this function right here. F of x is negative 2 times x minus 2 quantity squared plus 2, so a quadratic function. And the linear function they've given us is tangent to that function f of x at some point here. It says within the first quadrant, and they want to know all possible values of b. So a little bit of a weird problem, and as is often the case then, a graph might kind of help to illustrate what's going on right over here. So not quite sure. It just says we're talking about the first quadrant here, so I've kind of included the second as well, and let's see what we can draw out right here. So what I tried to do, I believe, if I remember where this is going, is to take a quick moment right here to sketch this function out. And you could graph this on the calculator, but come on, guys, it's in vertex form. It's going to be much easier to do this way. Our vertex with h and k is going to be at the point 2, 2. The negative leading coefficient means that this parabola is going to open downward, and that negative 2 means that it's going to be a little bit skinnier than a normal parabola. Remember, with a typical parabola, you'd go left 1, down 1, and you'd go right 1, down 1 from the vertex. But because our a value is 2, we're going left 1, down 2, and right 1, down 2. So that gets us our x-intercepts of 1, 0, and 3, 0. And that's probably a sufficient graph for what this one looks like right now. Okay, so with that in mind, we know that there's a line, y equals mx plus b, that's tangent to that graph at some point within the first quadrant. And they tell us that b has to be greater than or equal to a value of 2. So I'm going to switch the color of this to red once I can figure out how to do that. There we go. And let's go ahead and let's try to draw a couple of potential tangent lines here and see what this could look like. The first thing to focus on is the idea that they're telling you the minimum possible value of b is 2. That's probably important. So I'm going to go ahead and put a dot on the y-axis at some point here at a b value of 2. And draw what the tangent line would look like. And there's only one, there it is, that passes through the point 0, 2 that's tangent to this curve. And as you can probably tell, that's going to be a horizontal tangent line passing through 0, 2 and our vertex at 2, 2. That was supposed to be horizontal. Sure, let's go with that. So what we have right there is one possible tangent line. And in fact, what we're going to see here is that that tangent line right there is actually the maximum possible slope that this one could have. If I just randomly picked another b value like 5 and tried to draw the one and only point the only line that is tangent to the curve in the first quadrant, passing through the point 0, 5, it would look something like this line right over here. And what I think you can tell that's important here is that that second tangent line that we drew is going to have a point of tangency different than the first one. The first line, the horizontal's point of tangency, was 2, 2, but with the second line, when we made b go higher, the point of tangency crept a little bit to the right and a little bit down from where we were before. And it stands to reason that the farther down we go in this first quadrant, we're going to get a steeper and steeper tangent line at every particular spot. And when I say steeper, because these slopes are negative, the slope is actually getting less. But that red point that I drew right there at 3, 0 actually kind of indicates the last possible spot where that point of tangency could be. I changed it from a closed to an open dot because it says in the problem that the point of tangency has to be in the first quadrant. 3, 0 is technically not in the first quadrant because it's on the x-axis, and that's why I put an open dot. So what I'm going to try to do, and I always draw this badly, and this is no different, is to try to draw the tangent line passing through 3, 0, and I kind of have to curve it, otherwise I'm not going to fit it there, but let's pretend that's a straight line. And if we extend our y-axis up This point of intersection right here represents the highest possible value that b could ever be. If b was going to be anything higher than where we just put that dot right there, our point of tangency would actually move down here into the fourth quadrant, and that's not what we want. So at this spot way up here on the y-axis, that then tells us the biggest value that b could ever be. And our job moving forward now is to try to figure out what that upper value is going to be. My choices looking at the problem are 10, 12, 14, and 20, and we've got to try to figure out which one that is. So the 2 that I've circled is the lowest value we can ever have for b, and this guy up here on the top is going to be the highest value. So we're going to call that n for now, although I don't think I ended up using that anywhere. And let's try to come up then with, thanks Leah, let's try to come up then with, everybody, the equation of this tangent line passing through 0n and the point 3, 0. All right, well, if we know that it's a tangent line to this particular function, then it would probably be useful to find the derivative of f of x. So here we go. F prime of x is going to equal, and a little bit of the power rule right here, guys, -4 times x minus 2, and that's it. So there's our derivative, and we want to evaluate that derivative at a spot where we know that our x value of the point of tangency is 3. So f prime of 3 is going to get us a -4 times 3 minus 2, which is 1, and that's going to get us -4 for the slope of that steepest possible tangent line right there. So the slope of that tangent is -4. All right, so now, what do we know about this magical new tangent line? We know it passes through the point 3, 0. We know it has a slope of -4. And if we know a point and our slope, let's go to point slope form. How about y minus 0 equals -4 times the quantity x minus 3? And since we're talking b values, we probably want that in slope intercept form. So that's going to be a y is equal to a -4x plus 12. 12 is the y-intercept for that steepest possible tangent line right there, and that tells us what our value of n is, which is the greatest possible value of b. And so putting all that together here, guys, we now know that the minimum value for b is 2, and the maximum it could ever be is 12. So we can go ahead and write our answer as an inequality now, bounded in between these two values of 2 and what we now know is 12. So we're going to write this thing as a compound inequality. 2 is less than or equal to b, which is less than 12, not less than or equal to 12, because if we drew this tangent line, the point of tangency would be 3, 0, which technically is not in the first quadrant just yet. So our answer right here is 2 is less than or equal to b, which is less than 12, and our answer there is B.